So hello guys, welcome back to Gettobyte YouTube channel. The video which you have just seen is an encryption and decryption of an image using microcontrollers. And that's what we are going to learn and implement in today's video. We are going to learn how to use cryptography technology in microcontrollers and in embedded world. And for doing so, we are going to use the Electronics version 2 development board and the NXP Semiconductors S32 Design Studio IDE. Encryption and decryption is very important and basic concept of cryptography, and what we are going to achieve on doing the encryption and decryption of an image or a data to know how to use cryptography technology in embedded world. And for doing encryption and decryption, we are going to use the cryptography cipher AES algorithm using electronics version 2 development board via the C standard based CSEc peripheral. Now, to know about what all these terminologies which I have just now stated, and to know about the basic working concept and the understanding of cryptography, I would highly recommend to watch the following videos in following hierarchical order to know about these things. What is cryptography? How cryptography is implemented in automotive world, and basic concepts and terminologies in cryptography technology. Now, what I have done in this div project is I have taken an image and convert it into the string of bytes. After that, I have stored this string of bytes onto the electronics version to development board microcontroller memory, and then do the encryption through the AES cryptography algorithm on the stored data. On successful encryption, those string of bytes are converted into the encrypted form of string of bytes, and then I have processed send those string of bytes, encrypted string of bytes to the color LCD screen and printed the encrypted images in AES ECB and AES CBC mode. Sending the encrypted form of the data or the image to the LCD screen. But same way we can send this encrypted form of data to the other microcontroller or other ECU via CAN, LIN, UART, Ethernet or any other protocol. And this will be going to implement in upcoming videos. For now, we are going to do the simple div project statement of encrypting and decrypting the data using AES, ECB and CBC algorithms and passing those encrypted form of data to the LCD screen for printing the image. Now, to achieve this, we will be needing certain hardware and software tools. In the hardware, we'll be needing the electronics version to development board, which is going to be the brain of this project. J-Link V9 debugger to program and flash the microcontroller, which is present on electronics version to development board. Double breadboard to make the connections of electronics version to board with the LCD screen, and the ST7789 color LCD screen for printing the images and the data onto the screen. And in this software, we'll be needing S32 Design Studio IDE that will be used for programming, for writing the programs in microcontroller code for electronics version to development board, and LCD image converter using which we are going to convert the image into the string of bytes. Okay, so now I hope you guys have gathered all the hardware and software tools that I have mentioned just now. Now we are going to start with the practical implementation of this div project at first, and then going to delve into the theoretical part and understanding this thing in detail. Now for microcontroller programming on electronics version to development board, I have made a separate GitHub repository where I am storing all the codes of the all the codes related to the electronics version to development board. So if you will navigate to the Google and search GitHub electronics version to board, you will get its first link on the GitHub website. In that, you will be able to see there are right now two folders: peripheral drivers and sensor and module interfacing. As we are going to explore the first for peripheral drivers, and in that you should go to the CSEc. CSEc is the peripheral of electronics version to development board using which we are going to do the cryptography. And in that, I have made us some example codes which are ready to use and which we are going to use and for this div project problem statement. Now, so first thing that we are gonna do is we are gonna clone this GitHub repository into your local PC. So for doing so, copy the link of this GitHub repository from here, and then go to the folder structure or file explorer in your PC and create a new folder by the name of Electronics version 2. So I'm creating a new folder over here, Electronics version 2, and then make sure that you have installed the git into your PC. Right click on it, go to show more options, and open the git bash. Okay, now git bash will be coming up if you have installed the git to your PC. So, and it's a simple installation that you can do by referring to the Google also, or you can check out this above video link or this video in which I have properly explained what is git, how does git work, and how to set up into your local PC. So now just type in git clone for cloning the GitHub repository and copy and paste the link and press enter. Now it will be cloning the GitHub repository of Electronics version 2 into your PC, and then you will be able to see all the folder structure that was there, which you have seen in the GitHub, that is available over here also. Okay, so now you have cloned the GitHub repository into your local PC. Now go to peripheral drivers and go to CSEc peripheral. And in the CSEc peripheral, by the time you will see this video, you might see only these two videos, but in these two projects in the CSEc peripheral. But in the upcoming time, more projects or more codes you will be able to see over this location. And we are going to use this project. Now we are going to open this project into the Design Studio. Now, guys, after successful cloning of the project of the repository of Electronics version 2 into your local PC, now we are going to open this project and these example codes into your desktop. So for doing so, we are going to use the S32 Design Studio desktop application. S32 Design Studio IDE is a desktop application that is used for programming and debugging and doing the microcontroller coding for S32 based microcontroller family. And as Electronics version 2 board has S32K14 for microcontroller, so we'll be needing the S32 Design Studio IDE. To know more about and in depth about the S32 Design Studio, I would recommend to follow this playlist on S32 Design Studio, in which I have properly told how to use it, how to do software installation, how to do the debugging, compiling, and opening of the project. For the time being, you should just check out first video of this playlist in which I have told how to do the software installation of Studio Design Studio IDE and the installation of microcontroller packages that we'll be needing for opening this project, for opening these example codes onto the Design Studio IDE. So I hope you guys have installed the 3.4 version of Studio Design Studio. If so, so just search on the Windows and open the Design Studio 3.4. After that, it will be opening up, and it will be first of all asking you for to load the workspace. So go to the browse, we will create the new workspace, the documents by the name of Electronics version 2 workspace, and select folder and then just launch it. Now it might take some couple of seconds or couple of minutes to load the Design Studio ID when if you are opening it for the first time. So after you have your workspace will be loaded, you will be first of all seeing the first two these pages on the Studio Design Studio, the getting started page of Design Studio 3.5, 3.4, and this progress information. You can just cancel this progress information, and on the getting started page, you can just get some quick startup guides. But I will recommend watching my playlist on the Studio Design Studio, in which I have properly explained all the things, features, and how to use this Design Studio IDE. Now to open the project that we have installed in our repository that we have just now downloaded, go to the file and go to open projects from file system. Here go to the directory and go to the location where you have installed the your example codes. So Electronics version 2 peripheral drivers, CSEc, and this CSEc peripheral project, CSEc AES encryption CBC ECB with ST7789 screen and select folder. Now it will be loaded and go to the finish. Close this and click on this restore button. On clicking on this restore button, you will be first of all seeing the project explorer view, and many views are there in Design Studio. To know what all these things are and to know more about this menu bar and about the Design Studio, I would recommend watching my playlist in the hierarchical order. Okay, so now as you will open the project onto the S32 Design Studio IDE, you will be seeing there are many folders and .c.h files in this project. For the time being, you just don't have to worry and dwell into what all these files are and what all things that will be getting in the upcoming blog in the video. Once we understand and once we will do the practical implementation, and then we are going to reverse engineer it. So this is the project that will be opened on the Project Explorer with these things. Now go to the Project Explorer, right click on it and go to the properties section. Sorry, not on properties, go to the build configurations and set archive. By going this way, you will be able to see what all different example projects are there in this project. So there are 7 example projects that I have created, the basic day for doing the DIY projects. And these example projects you can see onto your screen and in your Design Studio IDE. First thing that we are gonna do is execute the fifth example, CSEc crypto engine init. This will initialize and configure the CSEc peripheral in our S32K144 microcontroller, which is mandatory step if we want to use the CSEc peripheral. And after executing this fifth example, we are going to execute the sixth example, which is CSEc AES CBC ECB encryption image. That is the code which is being flashed into the controller, and for which you have seen the video in the starting of this video. Okay, so to select the project, click on the set archive and then click on the project that you want to open, and corresponding example project name you will be able to see here. Okay, now click on it and go to the project, click on build project. Now your project building will be starting up, and you will be able to see your project explorer, build project, and console will be showing the compilation process. Okay, so once the project is compiled with zero errors, there might be some warnings. So you can ignore the warnings for the time being, but the zero errors should be come up. Okay, now we are going to flash this example code. Now you able to see in the when you started the building the project, a CSEC crypto engine init folder is created, which is the name of your example project, and in that you will be able to see the L file for your project. Okay, so this L file is now we are gonna load into our electronics version 2 development mode. Now, after you have compiled the crypto CSEC crypto engine init example and done all the hardware connections that I have just stated, it's time to flash this L file into our controller. So for doing so, we have to do the certain debug configurations onto our S32 Design Studio IDE so that it can communicate with our hardware. And for doing so, click on your project and then go to the run and go to the debug configuration. And in the debug configuration, you will be seeing the different hardware tools that are supported in S32 Design Studio for programming and debugging of the controllers. And we are using the Sager J-Link debugger. So we will click on it and go to this plus sign, new launch configuration. On doing so, a new launch debug configuration of your project will be automatically created. Now here we have to do certain configurations. In the CC application, go to the browse and select the L file that is just compiled for your project. So here you will be redirected to your project root folder. Okay, and then go to CSEC crypto engine init, which is your example project name, and select the L file. Okay, and then you will be able to see here your the L file path is selected, and in the build configuration, click use active. Another change that you have to do, go to the debugger tab, and here you should write the device name as S32K144. Sometimes it might happen that in some users this device name is missing, so you have to type it manually. Another change that you have to do is this change, the third change that I am telling, this has to be done only in the CSEC crypto engine init example and not any other example project that I am going to tell furtherwards. In this, go to the startup and click on runtime options as RAM application. This must be disabled by default, and check on it so that your application is loaded from the RAM application, because RAM memory. Why? Because for configuring the CSEc peripheral, we have to run this example project CSEc crypto engine in it from the RAM memory of the controller. Okay, and then click on the debug. Now, as you click on the debug, you will be able to see there will be a launch configuration file will be starting to launch, and just wait for a couple of seconds. Now, after this, you will be able to see that your debug configuration and perspectives are working properly. In the debug perspective, you can see the main function in the your .c file of your corresponding example project, CSEC crypto engine in it, and it is stopped at that main function starting only. And now we are going to use these three icons are very important that we'll be using very extensively. This is step into. Okay, this is step over, and this is the resume. So if we click on the resume, your code will be executed in single one go. So right now we are just going to do that only, and you can see in the hardware. Okay, yeah, this one. So your hardware no LED is currently blinking, or it is light up. After the successful initialization of crypto engine in it, your green LED will light up. Okay, so now let's just see that thing. So you can see this, your green light up means your crypto engine in it is been successfully done. Okay. Now, if you will relaunch it, you will rerun the crypto engine in it example by clicking on it and terminate and relaunch. Okay. So now, as you have done the CSEC crypto engine in it initialization, okay, so your CSEC register is set and it will be asking, keep coming up with this warning every time, first time. Okay, so now if we click on it, go, now you will be able to see here your red LED will light up. And this is because it red LED here in this example project means that your CSEC crypto engine init initialization is already done. So there are two if conditions that I have written on this. If flash init for CSEC is successfully done, then your green LED will be lighted up. And if your flash init for CSEC is already done, as we have run this example project second time, so your red LED will light up. Okay, so in both of these case, it means that your CSEC initialization is done. Now what we are going to run, we are going to run the another example. This is the, as I have told, first example project that we have to run always at first time when we have to use the CSEC peripheral for the first time. Now once we have done the CSEC initialization and configuration, we don't have to run this example project again and again. Now we will just change our build configuration. Okay, set archive, go to the build configuration, go to the set archive, and go to the sixth project, CSEC AES CBC ECB encryption image. In this project, it will be going to encrypt the image which I have stored in the microcontroller, which in this array. Okay, and how I have created this get to byte, this string of bytes of an image, as I have told in the earlier part of this video, of when I was telling about what softwares we are using the LCD image converter software. Okay, so this is the long string of bytes of the original image. I've stored that onto the memory of the microcontroller with the special section creating by the crypto encrypted and crypto plain image. Okay, and then I will be encrypting this image. Okay, by using these APIs, encrypting ACP and encrypt CBC, and then printing on the LCD screen. So now we are going to do this thing. So now for this also, at first we have switched to our example project. Go to the project and go to the build project. Okay. So your example is now builded with these zero errors and zero warnings, as you can see over here. Not zero warnings, but zero errors. Okay, and now we are going to create the debug configuration for it. Go to the run, go to the debug configuration, and under the J-Link debugging, we will go and launch our new launch configuration. And same process for here also. Here we only have to do two steps. First, we will locate for the CC++ application, and now this time our project is a CBC ECB encryption image. Okay, so and click its .l file, open, and your file will be loaded. And just make sure in your debugger tab in the device name your S32 K144 is there, and the build configuration we will use active. In this we don't have to make the change of RAM application in the startup, so we will uncheck this RAM application because we have to load the from the RAM memory only for the CSEc crypto engine in it and CSEc crypto erase case example. For all other examples we are going to run the code from the flash memory of the controller only. Okay, and then click on debug. Now your launch configuration will be loaded up and it will be getting loaded over here. It will be loading, and let's divide the screen in two parts for your better understanding. Here is the hardware that you can see, and here is the code. Okay, so now it will be again as the debug perspective will be opened, and it will be showing you the .c file of the corresponding example project. Now we are using AES CC encryption, and it is stopped at the main function of that example project .c file. And now if we click on the go, so let me just divide the screen again. Okay, and let's just click on the go. So now you can see your screen is getting loaded. Original image is this, ECB encryption of the data of this original image is this, and CBC encryption of this image is this one. Okay, so yeah. So that's it for this video. Now in the next video, we will dwell into CSEC peripheral and C standard to know the internal working of cryptography technology in microcontrollers.